This video is an overview of forces and a description of some common forces we'll look at in Physics 7LC. So intuitively we can think of forces as pushes or pulls. If you punch on somebody, even if you're sitting in a chair right now, you are pushing down on the chair. Now also, because you're not falling into the ground, the chair is pushing back on you. And that's important. A force is actually caused by a mutual interaction between two objects. So if we think of, having two objects, A and B, for example, if we have B pushing on A, well, that's B exerting a force on A. But whenever this happens, A also exerts a force back on B. So Newton's laws of motion are three physical laws, and they let us describe the relationship between forces that are acting on an object and then the object's resulting motion. So we'll be practicing a lot drawing objects, drawing the forces on the object, and then using our diagrams to tell us what happens to the object. So it's really crucial to understand what a force is. And this week and next week in our tutorials, we're going to develop this understanding and see the relationship with Newton's three laws. So an object, as you can see in this drawing that I just drew, it can have one force, no force, or many forces acting on it. And its resulting motion is due to a combination of all of the forces acting on it. So we use the term net force. A net force is the combination of all the forces acting on the object. So we figure that out by actually just adding all the forces together. A force is a vector because it has both a magnitude or a size of the force and a direction. If you push or pull, you have to push or pull in a certain direction. So those are vectors, so we can add those vectors together. I can redraw F2 over here, and then you can see in green this vector here that goes from the tail of the first vector to the tip of the last vector. That is the net force, the combination of all the forces on it. So now let's talk about some common forces that we'll be looking at in class. The first is gravitational forces. So anytime you have two objects, 1 and 2, for example, if those objects have mass, then those two objects attract one another. So object 1 feels an attractive force pulling towards object 2. Object 2 feels an attractive force pulling towards object 1. So in most cases you encounter the Earth is the predominant gravitational force because the strength of this force depends on the mass of the object, and the Earth has a much larger mass than anything else nearby. So usually if we want to calculate the net gravitational force on an object, we can ignore all the other objects around it, not because they don't exert gravitational forces, but because the size of the gravitational force is so small compared to the size of the Earth's gravitational force. So the term weight of an object, weight, we hear this term colloquially. You'll see this represented by F sub g because it stands for the force due to gravity. Sometimes people will write it as a W. But what the weight of an object is it's the net gravitational force acting on an object. And again, since the Earth has so much a larger mass than anything else around it, we usually think of the weight as the force of gravity on a particular object due to the Earth. The next force that we'll think normal force. So normal force, which is usually denoted F sub n, or sometimes n with a vector. It arises from the contact between one surface on a second parallel surface. So if you, for example, have a box and a table, then the bottom surface of the box and the surface of the table are touching each other, and so a normal force arises between the contact of those two surfaces. Now the name normal actually means perpendicular, and so the normal force is always directed perpendicular to the surface. So the table pushes up on the box, and that's what keeps the box from falling through the table, and the box pushes down on the table. The table feels a force from the block, and those are both in the direction perpendicular to the surfaces. So physically, the normal force comes from electrostatic forces that hold matter together and prevent it from deforming and breaking. You're not responsible for those details in this class, but in general, the contact forces that we talk about have a deeper origin. Now you should be aware that normal forces also happen if the surfaces are not horizontal. For example, if we have a vertical wall like this, and say we have a book that we're holding up against the wall with maybe a finger, a hand, if we were to look at what's happening with this book, well, it has the hand that's pushing on it towards the wall. That's a normal force because the two surfaces are in contact. We have the wall pushing on it outwards, again perpendicular to the surface, which now is horizontal. We also always have gravity that is pulling down on the book because of the book's mass. The last force that we'll talk about is frictional forces. So frictional forces also arise between the contact of two surfaces, but frictional forces, unlike normal forces, act parallel to the surface. And the job that frictional forces do is they slow down objects. When objects slide, that's a particular kind of friction called kinetic friction. So if you are moving, like a box is sliding across the ground, it comes to a stop. That's because of kinetic friction. But there's a second kind of friction which prevents objects from sliding in the first place. That's called static friction. So if we look back at what's happening with our book that we drew here, we see that the force of gravity is pulling the book down, but there's a case you can imagine where the book is actually staying steady against the wall and not moving. So in this case, the force that is pulling the book up and causing it not to fall is the frictional force between the book and the wall, and there may be also a frictional force between the book and the hand that pull it up. But that frictional force is static friction because the book isn't sliding at the time, and so the force that's preventing it from sliding is static friction. So friction can get tricky, like for example when objects are rolling, and we're not going to deal with that for quite a while in this class, but I'm very careful to give you guys the definition that static friction is the friction that prevents objects from sliding, not that prevents objects from moving, because as you'll see later when we get to rotation, it's static friction that allows wheels to be able to roll, which is a motion. So static friction stops things from sliding, and kinetic friction slows things down when they're sliding. The last thing I want to mention in our force overview is the two categories of forces we'll talk about in this class. Those two categories are field forces and contact forces. So field forces we'll only talk about one in this class, and that's gravity. And for a force to be a field force, the object doesn't actually have to be in contact with anything to feel a force. So you know that if you have a ball in the air, it's going to fall down towards the earth, even though it's not directly touching the earth's surface at that time. That's because gravity is a field force. The object doesn't have to touch the earth to feel the force. All other forces we'll deal with in this class are contact forces, which means that if you want to exert a force on an object at a moment, you have to be touching that at that moment. There is no action at a distance or exerting a force on something without touching it, unless that force happens to be gravity.